Yeah, hello guys. Yeah, welcome back to my channel. This is Chemistry Call. It's been a while that I deposit a video on this channel, but today we'll be starting with electrolysis, and based on that syllabus of those that are preparing for the forthcoming examination, I mean those writing UTME exam. So today we have to look at one of the topic which many students find difficult to understand. So now, what do you understand by the concept of electrolysis? So before I give you guys the definition, we'll be looking at the terms used in electrolysis, which are the electrolyte, the electrode, anode, cathode, and electrolytic cell. So class, let's start with electrolysis. So what is electrolysis now? So we can say electrolysis is a chemical decomposition of a compound, either in molten form or solution, by the passage of electric currents. So now, when we look at this particular thing now, we said electrolysis is a chemical decomposition of a compound either in molten form or in a solution. How do we see that thing? So when we look at this now, I have this is a positive, I have what? This is a what? A negative. One thing you should note when it comes to the passage of electric current, the positive ion, which is this, migrates to a negative cathode. The same thing to what? A negative migrate to a positive anode. So when we look at these two things now, you tell us that when in our domestic home we have what we call the sockets. Those two sockets has to what we call what? Wire. The one is black, one is red. So we can denote that to what? A positive ion and a what? A negative ion, because we talks about the decomposition of a compound either in molten form or a solution by the passage of what? Electric current. So now I say a positive ion migrates to a negative cathode. So they are telling you directly that if we are given our electrode, we have two carbon rod, the anode and the what? The cathode. But when we start the terms used in electrolysis, that will explain more. So now, when we look at the terms used in electrolysis. So the first one is electrolytes. Sorry, we have what we call electrolytes. Are you with me now? So these electrolytes, under it we have what we call the strong, we have the weak, then also we have the non-electrolytes. So I'll be picking one after the other. But to the jam bite, where can you find your question most? Jam will always ask you a question based on the terms used, but you have to know the example of each of these terms used. And mainly when we talk about this electrolysis in jam, then we ought to explain the concept of the calculation, the Faraday first law, the second law, and also how we can solve each of those questions. So as a jambite, they are preparing for the forthcoming examination. If you don't understand the concept of this electrolysis, you will find it difficult to attempt some question on electrolysis, because mostly jam always play with calculation. So now let's go back to what we have on the board. And again, don't forget to subscribe, like, share among your friends. So what is electrolyte? You can say electrolyte varies with the definition of electrolysis. The same thing. So I can say a chemical chemical decomposition of a compound. Either in molten or solution by the passage of electric currents and decompose at the electrode. So look at what we have on the board. There's only little difference between the definition of electrolysis and electrolyte. Why? Because electrolyte talks more about the composition of a substance in which electric current pass through it. But there is one difference between this electrolysis and electrolyte. They decompose at the electrode. And when a particular thing decomposes at the electrode, they are telling you directly that electron can enter or leaves the electrolyte. Are you with me now? So now class, let's take a look at the strong and weak electrolytes now. So we have the strong electrolytes. So this one talks about a compound ionize completely in aqueous solution and conducts large current of electricity. So class, when a compound or a substance ionizes completely in aqueous solution and conducts large current of electricity, indirectly they are telling us there is always free movement of electron. So with that, I can say that I have sodium chloride. So I have this positive and this was negative. So there is free movement of electron. So with that, and anyway you have a free movement of electron, they are telling you that they conduct large currents of what? Electricity. So my example of this strong electrolyte is we have the mineral acid, most soluble salt. The example, you have to take note of this. Alkalis. And mineral acid, under our acid and base, which later we are going to discuss more on it. We talk about the mineral acid. Those are the man-made acid. The likes of sulfuric acid, your H2SO4, your HNO3, either your strong or weak acid, they have been classified as what? Mineral acid. So now, let's take a look at the second one, which is what? Weak electrolytes. Sorry? The weak electrolytes. So now, I can say for weak electrolytes, they are the same thing. Just that if one is conducting more electricity, one will conduct less electricity. And if one should ionize completely, then vice versa, the other will either what? Ionize partially or slightly. So I can say this is when a compound ionized partially or slightly in aqueous. In aqueous solution. So example of this, we have organic acid. So we have citric acid, then we have lactic acid, and more. So class, when we look at this weak electrolyte, when the compound ionized partially or slightly in aqueous solution. Oh, sorry, I missed one thing here. So when they ionize slightly or partially in aqueous solution, then they are, let me say, they conduct less, or they do not conduct electricity. But note one thing, in chemistry, many have been asking if water probably or possibly belongs to strong electrolyte or weak electrolyte. No, water belongs to weak electrolyte. Why? Because when we look at this example of ammonium hydroxide, so this is now. So this one here is our ammonium. Losing one electron. And when you lose an electron, we are becoming less, or let's say we are becoming less or partially to a particular compound that will undergo what we call complete ionization. Are you with me now? So now, water, notes. Water is a weak electrolyte. Jambite, take note of this. Water is a weak electrolyte. The last one for these non-electrolytes is that non-electrolytes, they do not conduct electricity, nor they conduct or they ionize. Rather, they are mainly organic compound. And when we look at the word organic chemistry, which I've dropped the video last year, there are many organic compounds and they are covalent in nature. Are you with me now? So mostly non-electrolytes are covalent compound. Are you with me now? So let's go back to the terms used in electrolysis. Where we have the next one, number 2. This one is number 1. Then number 2, we talk about electrode. So we talk about electrode. So class, what is electrode? They contain a rod that is a carbon pole. Let's say carbon, in which electric current leaves or enter the electrolytes. And if an electrode can contain a rod, a carbon pole, and that carbon pole is what? 2. So class, the 2 carbon pole that we are going to look at now have been mainly classified as under the terms used in electrolysis. The third one is what? Anode. The fourth one is cathode. While the fifth one is electrolytic cell. So class, when we look at this electrolytic cell for this terms used now. So class, for this anode, we can say an anode is a positive electrode in which electric current enters or electron leaves the electrolytes. Again, an anode is a positive electrode in which electric current enters the electrolyte or electron leaves the electrolyte. Again, anode is a positive electrode in which electric current enters or leaves the electrolytes, or electric current enters, should not use the 2. Electric current enters or electron leaves the electrolytes. So class, in JAM might not put their question that the 2 carbon pole of an electrode in which electric current leaves the electrolyte is dash. As a JAM bite or a student preparing for or to write examination, you should be able to differentiate between the one in which electric current enters or the one in which electric current leaves. For anode, electric current enters. I'll use me now. So let's take a look at cathode. Cathode is a negative electrode in which electric current leaves the electrolyte, or electron enters the electrolytes. So class, this is the main thing we ought to understand, because if you don't understand the concept of electrolyte, electrode, anode and cathode, then to be able to explain this electrolytic cell will be very, very difficult. So class, I will explain the electrolytic cell here, then I will sketch out the diagram over there. So class, what is electrolytic cell? Electrolytic cell contain this container. These are containers which contain 2 electrodes by suitable direct current supply. I can take this one to be my battery. So class, under this electrolytic cell, these are containers which contain 2 electrodes by a suitable direct current supply. One thing you should note here, JAM might not have it for the definition of this, but we want to know 2 things under this one here. Oxidation occur at anode, reduction occur at cathode. So class, let's take a look at those 2 electrodes. So I have this is my container. So this is the first pole, and here is the second pole. I have this to be my negative, this is my positive. So this is what? The container which contain the electrolytes. Then I have this. Then I have this. We call this one the electron flow. Why this one is a battery. So this goes like this. The cathode, the anode. So we call this one the electrode. Then what we have inside is our electrolytes. So this is a simple electrolytic cell. So class, I'll stop today. Tomorrow we'll take a look at the first and second Faraday law of electrolysis, where we'll be solving different examples and questions related to those writing down. Thanks for watching. Don't forget to subscribe, like, and also want to appreciate the effort of our subscribers. Thanks.